When we talk about AI in nuclear operations, we're talking about everything from, AI-enabled spell check and editing on policy documents, all the way up to kind of an artificial intelligence advisor telling the president of the United States whether or not he or she should think about retaliating to an attack that may or may not be incoming.
Hello, and welcome to AI Curious. My name is Jeff Wilser. I'm a journalist, I'm a human, and I am curious about AI. In 1983, a Soviet officer named Stanislav Petrov was watching a screen when it told him the US had just launched its nuclear missiles at Russia. His job in that moment was simple: pick up the phone, pass the warning up the chain, which of course could lead to nuclear war. Instead, he paused. He decided, using human judgments, that it looked wrong. Something seemed off. And he sat on his hands. Turns out he was right. That was the right call. The thing he saw was a glitch, a trick of sunlight on the clouds. Now, you can maybe make the argument that that one human, Stanislav Petrov, refusing to blindly trust the machine, averted World War III and is why you're alive to hear this podcast. Now, let's imagine that scene again, but at warp speed. Lots more missiles appearing to be striking, and less humans in the room. And then add an AI quietly whispering to the machine, "Go, attack." That is the territory today's episode explores. These are the stakes. And here's a twist. My two guests are not doomsayers. They're amongst the most level-headed people I've had on the show. They're not spending time on Skynet and Terminators. Instead, they're focused on the boring, real, and genuinely unsettling stuff that's already happening is plausible in the future. Those two guests would be Ankit Panda, the Stanton Senior Fellow in the Nuclear Policy Program at the Carnegie Endowment for International Peace, and author of The New Nuclear Age, and Andrew Reddie, a professor at UC Berkeley's Goldman School of Public Policy and faculty director of the Berkeley Risk and Security Lab. These are, in short, two of the planet's leading experts on the risks of nuclear war, and more generally, how things could go sideways. We get into all of it, the full spectrum of risk, and we're going to cleanly walk through that risk spectrum from the simple stuff, AI spell checking a policy memo, innocuous things, all the way in the other end to an AI advising a president on whether to retaliate, and why the scariest near-term threat is not killer robots, but cyber attacks. We get into the dead hand doomsday systems that actually are real and still out there, and why, for now at least, they tell you to not build that fallout shelter, and we end on some actually hopeful stuff. So with that, please enjoy my conversation with Ankit Panda and Andrew Reddie. Andrew and Ankit, welcome to AI Curious.
Thanks for having me, Jeff.
Yeah, thanks so much.
All right, let's just start with some basic intros and what you guys are focused on. Andrew, let's start with you.
Sure. So I work at the intersection of technology and international security issues. Over the last 10 years, that's meant looking quite closely at how AI technologies are transforming the defense technology space and implementations, both on the conventional warfighting side and then also on the nuclear side as well.
Awesome.
So I pretty much think about nuclear war 7 days a week. I work in the nuclear policy program here at the Carnegie Endowment. My work runs the gamut today of everything from nuclear strategy, how the United States should think about the prospect of nuclear conflict, nuclear deterrence in a changing global nuclear environment, how technologies, including AI, are changing the risks that are inherent, that have long been inherent in nuclear operations. And I also do quite a bit of work with American allies and partners around the world. So I've just returned from a pretty lengthy trip encompassing parts of Europe and Asia. So those are some of the things I think about day to day.
Awesome. Well, Ankit, since you think about nuclear weapons, nuclear war 7 days a week, let's start with you here. I think when most people hear AI and nuclear weapons, their first thought, real talk, is like War Games, the movie, right? One of my beloved movies from childhood. So why don't we start with that, the obvious movie kind of like baseline a lot of folks have. What is, maybe like if you can give us a lay of the land of what is actual reality? When you're thinking about this, when you're thinking, especially with AI and nuclear weapons, what are the main kind of like buckets of risk and that you keeps you up at night at 2 a.m, and we'll go from there.
Yeah, sure. So I think the place to start is actually to point out that the domain of folks, particularly in the United States, that have been involved in thinking about nuclear operations have been thinking about artificial intelligence, that particular term, for a very long time, really since the 1950s. By the late 1950s, the U.S. Air Force is sponsoring research into computational approaches to military science. And of course, what I'm getting at here is that AI does not mean what it did in the late 50s as it does today. So today, when folks talk about AI, everybody's talking about transformer-based large language models, largely speaking. But in the 50s and throughout most of the Cold War, basically what we were talking about in the nuclear world was what you might call good old-fashioned AI or symbolic AI, basically computer programming of the kind that's legible to human beings. Inputs and outputs are easily correlated. You don't have as much of a black box problem present there. And so nuclear operators have been interested in trying to understand the ways in which computation essentially can render extremely high consequence military operational tasks more tractable. And so that includes everything from, let's say, early warning, which is something the U.S. cared about quite a bit during the Cold War. I mean, every country cares about early warning, but I'm just going to use the U.S. as an example. Understanding whether a given input to your, let's say, radars and satellites was actually a real nuclear attack. There's all kinds of stories from the Cold War of where computers get that kind of thing wrong. Yep. And so fast forward to today, it's less the war games and Terminator stuff that people think about in the nuclear operational domain. But now with artificial intelligence systems, LLMs, and similar transformer-derived models, there's a lot of thinking about the ways in which that might be integrated into intelligence, classification tasks, into early warning, decision support, which is more controversial than some of those applications. So there's a gamut, right? Some people like to kind of point out that when we talk about AI in nuclear operations, we're talking about everything from, AI-enabled spell check and editing on policy documents, all the way up to kind of an artificial intelligence advisor telling the president of the United States whether or not he or she should think about retaliating to an attack that may or may not be incoming. And obviously, the level of risk involved in those two applications is pretty distinct. So let me stop there, and happy to pull on any of those threads. And I'm sure Andrew can as well.
A ton of follow-up questions there, but Andrew, I'm going to get your take on the kind of overall lay of the land and the kind of what domains or buckets of risk are you most focused on, and what would you say is kind of the things we should really be talking more about?
Yeah, it's interesting. You've got probably two of the more sanguine voices in this space with Ankit and I, and there's lots of agreement between us on these topics because we are so focused on kind of what's actually proximately here and now, and not kind of Skynet and Terminator, which is taking up a lot of the oxygen in the room. I mean, very similarly to Ankit, I kind of think about decision support ecosystem in terms of use cases moving from left to right in terms of there being risk associated with AI integrations. And those AI tools that we're talking about take a variety of flavors. So Ankit talked you through kind of GoFi, good old-fashioned AI systems, so rules-based architectures. We've used those for 70 years, particularly for intelligence, surveillance, reconnaissance purposes. The failure modes are relatively well understood. Indeed, in the nuclear space, we have dual phenomenology to try to deal with that reality. So, for example, you want to have two entirely independent sensors making a determination of launch on the part of an adversary. So a radar architecture that's entirely separate from a space-based architecture. Now, one of the potential dangers now in terms of the generative models being deployed inside of these spaces is the models are data hungry. And so you might want to actually start to pull some of these data sources that used to be kept separate together. And once you push them together, you can no longer pull them back apart because we don't have explainability over the system.
Can you spell out a little more? That strikes me as a really important point. Can you kind of walk through that a little more granularities? I think it's a lot of folks are not appreciating what you just said.
Yeah. So in intelligence, surveillance, reconnaissance, you're taking in all sorts of different types of intelligence information. So human intelligence from the Central Intelligence Agency, signals intelligence from the National Security Agency, image intelligence from any number of other intelligence orgs. And the 9/11 Commission report kind of makes clear that one of the dangers of that reality is that we end up stovepiping information inside of very particular organizations, and then that information doesn't get shared beyond that. And so there's been an effort institutionally to create the Office of Director of National Intelligence to pull all these sources of information together. Now, one of the potential nice things about AI tools is that you can actually build models that are able to ingest lots of different types of data, right? It doesn't have to be set up just for radar data or just for image data or just for synthetic aperture, right? It can be able to ingest anything. The trouble with that is that once you've actually ingested it, you're no longer able to go back through it and say, okay, which piece of information was actually the smoking gun is giving me the insight that an adversary has indeed launched.
Just to kind of that, just as right now, if a chatbot gives you, if you ask about, hey, I'm curious about the life of George Washington, it is not going to be able to tell you, I got this source from this biography written in 1914, this one from here. It's like it's a big black box. We have no idea where it came from. Am I getting that right?
Yeah. So variously over the last year and a half, we've thought we've kind of solved the explainability problem, but we just haven't. Anthropic, amongst some of the frontier model firms, is really working hard on the problem set. And of course, if we were able to do that, that would be great. But sitting here right now in June of 2026, we don't have explainability. And so when you start to munge all of these data sources together, there's a real risk that you're not able to then pull it apart, which really matters to the policymaker, right? Because a policymaker, when they get material from an analyst, is going to ask why, right?
Yeah.
What is the piece of information that's driving this insight? And so that's just the ISR piece.
And I cut you off, Andrew. You were explaining this, and I jumped into elaborating.
Yeah, so that's the ISR piece. I mean, as you keep moving to the right, particularly as we think about,
listeners, can you spell out what ISR means for listeners?
Intelligence, surveillance, reconnaissance.
Great, thank you.
Yeah. So as you move from ISR, you've got predictive maintenance, predictive logistics. Again, we've been doing this for a better part of 20 years at this point. Implementing AI into the various different, both military, conventional, and then also nuclear logistics chains, and has proved very fruitful. If things go wrong, the failure modes are relatively innocuous. Then from there, you move into courses of action generation or COA generation, wargaming applications. This is where you might use some of these tools to come up with doctrine. And indeed, after some of the senior policymakers saw tools like DeepMind's AlphaGo, right, playing the board game Go and coming up with strategies that no human had played before, there was a lot of kind of excitement, and we can kind of talk through whether that.
Am I right as you describe this like progression from left to right of like essentially, whether it's like the severity or stakes, or as you move to the right? At every link of this chain, AI is both a risk and concern we have to have new solutions for and make sure we're hardening the processes to accommodate this risk, and also potentially a tool we can use to improve our processes, right? Like you mentioned 100%. That so am I getting that right? That's you have to be thinking at every step of the way how AI is useful to improve things, and also, oh shit, there's a whole new risk vector we have to be aware of thanks to AI at every step of the journey.
100% is opportunities and risks.
Yeah.
And the military, I mean, and not just the U.S. military, militaries across the globe, right, are trying to capture, right, all of those opportunities whilst dealing with those downside risks. And I will say, like, Ankit and I's work is focused on making sure that we deal with those risks, and so perhaps we over-index on that. But certainly
someone should. I'm glad there are people out there over-indexing on nuclear and AI risk. That feels like, of all the things to over-index on, that feels like a pretty worthy target. So
I mean, just to jump in here for a second, like the nuclear domain in general, it goes without saying, we deal in the realm of extremely low probability, extremely high consequence events, right? Nuclear wars don't happen. We hope they never happen, but the possibility that they can happen is very real because we have nuclear weapons in the world. We have organizations that steward these weapons, military organizations here in the US and elsewhere that care about these things. And so the task when it comes to understanding the effects of any technology that kind of gets thrown into the mix, really since 1945, is to kind of look at both sides of the ledger, right? And AI is another technology in a long string of technologies over time that has caused nuclear operational planners to think about things slightly differently. And the opportunities and risks framing, I think, is really important. When this conversation first kind of cropped up in the broader policy world, the conversation was really fixated on human in the loop. It was this concept that was pretty easy for even multilateral diplomats who have no familiarity with nuclear weapons technologies, much less AI, to wrap their head around. Computers shouldn't be launching the bomb, right? That's a pretty intuitive concept. Since then, and this is really in the last 2.5 to 3 years, Andrew and I and a whole bunch of others have tried to convene, do a lot of research and writing about the kind of the far richer tapestry of applications that's out there. We haven't even talked about cyberattacks, cyber reconnaissance in the context of nuclear command and control systems. We're having this conversation shortly after the Fable Mythos moment, so to speak. So there's a lot of anxiety about that particular issue. And then, if I can just make an observation on nuclear strategy, one of the things I spend a lot of time thinking about in my work when it comes to any technology. I published a book last year called The New Nuclear Age that has a whole chapter on technological change that focuses on AI. But it's looking at how AI actually shifts the balance of, or at least the perception of the balance of power in a way that might create what in the nuclear world we call crisis instability, which basically means does it give countries a greater incentive to think about using their nuclear weapons first because they might lose access to those weapons, either as a result of a cyber attack or as a result of a preemptive attack. And here, this is a long-standing problem that we've dealt with in the nuclear world. When a ballistic missile-capable submarines arrived by the late 50s and eventually into the 60s when they were widely deployed, that was very significant technological change that was ultimately really stabilizing, because what it meant was that it gave the US and the Soviet Union a lot more confidence that their weapons would be immune to a preemptive strike from the other because they were underwater and the oceans are big and it's really hard to find submarines. That still is broadly true of submarines. With AI, the problem, you can kind of think of it in this way, is the integration of AI in some of the ways Andrew was talking about in kind of those ISR, intelligence, surveillance, reconnaissance applications, going to make it a lot more difficult for countries to keep their nuclear weapons systems safe, secure, and survivable. Because if the answer to that question is yes, and maybe not even yes in reality, just yes in the perception of leaders, like let's say if Vladimir Putin wakes
theory
up,
matters, right?
Yeah, like if Vladimir Putin wakes up and he thinks that the Americans have rendered the oceans transparent and Russian nuclear forces are no longer survivable, that's a really bad outcome for the US-Russia strategic balance that is completely divorced from the technological reality of what's happening. So there's a lot here that, we can unpack, but just wanted to add that to the conversation.
No, thank you for that, Ankit. And Andrew, you were still sketching out the left to right progression. And I want to make sure that we hit like the big ones. Ankit mentioned cybersecurity, and I can only imagine like the attack vector of command and control centers is suddenly there's a lot more ground to cover, I would guess, with AI. So I'm curious where that falls on this chart you're kind of sketching out for us, and then would love to hear the rest of your kind of the map that you're creating for us.
Yeah, so from that kind of wargaming and code generation, then it's a question of, well, where do you want to go and hit, right? So there's the targeting applications. And so this is actually what's been in the news the most in the context of AI military integration over the last probably 2.5 years, right? So you've had Gospel and Lavender used in the context of Israel and Gaza, which is arguably an AI decision support tool, right? Used for targeting purposes with a generative model living on top of a targeting algorithm. And one of the reasons,
we mean drones, right? This. I mean, we haven't mentioned drones yet, but I imagine this is as a pretty big.
Right. That's the next one to the right.
Okay.
But this is purely okay. This is purely just target selection. So this is still in that realm of, okay, you've got all of this intelligence. What is it that you want to go about actually prioritizing in terms of there's lots of different things that you're going to be trying to maximize for as a targeting officer, right? So you want to hit high value targets. You want to decrease the risk of friendly fire. You want to decrease the risk of fratricide, right? Your weapons taking each other out before they get to the target, etc. And so we've long relied on algorithms to help us do this. Now, some argue because we were starting to layer some of these LLMs on top of targeting algorithms, we're able to supply hundreds of targets in a day, whereas previously we were only able to get kind of 1s to low 10s of targets in a day. And so, scholars and analysts are still kind of parsing out the ways in which using some of these tools in the targeting use case is really changing the game. The reason, of course, that you want to start to rely on some of these tools is that in the wars that we can imagine in the future, you're not going to have a very docile environment for carrying out targeting, right? You're going to have the need to put assets on new targets in real time, reflecting the real world demands of the battle space. And of course, you're going to have jamming and all sorts of other things going on as well. So it's, your adversary is going to have a vote there. And so basically using some of these AI tools increases the likelihood that you're able to actually target the right things at the right times. Now, of course, you also get some of the conversations about some of the drawbacks of that. So you probably saw the headlines around in Iran, a U.S. targeting mistake where an IRGC base was subsequently a portion of that IRGC base was turned into a school, and that school ultimately ended up being a target during the U.S. exercise in the country. And so that led to a lot of conversation about kind of the AI-ness of it all and what was appropriate or inappropriate. So that's kind of the targeting piece. And then finally, the last one all the way on the right is autonomy. And so that's where you get into drones on the conventional side. And then potentially also on the nuclear side, when you think about assets like Poseidon, which is one of the newfangled Russian systems, and then also the potential of dead hand systems. So that's the notion. There was the perimeter system in the Cold War that was kind of a set it and forget it, so a human can like flip the switch that turned it on. But this is the idea that you would have an asset that would launch nuclear weapons without human input upon receiving information that nuclear weapons have been launched against their state. And so that way, right, there was always this threat of punishment, regardless of whether you were able to decapitate senior leadership.
Out of curiosity, does that exist? Is that a theory, or does it exist now? Or are you allowed to say, is that classified if that dead hand system is in operation?
So the Russians still are thought to maintain that system. They don't keep it enabled in what we call peacetime, right? It's basically designed to be activated. And again, here you have to get into the realm of nuclear strategy. People, we sound a little crazy when we describe this stuff in the nuclear world, but what makes nuclear deterrence tick is the promise of assured nuclear retaliation, right? So if you're up against a technologically sophisticated country like the United States that you're worried is going to be extremely good at potentially prosecuting targets with nuclear weapons in your country, to include potentially your national leadership. Basically, the idea that in a nuclear war, the Americans might take out your leadership and your nuclear weapons before you can even blink. I think that's a little exaggerated, but some Russians probably believe that. You're pretty rationally incentivized then to set up something like this system. The North Koreans actually are the latest to join that club. We don't know if they've actually built a so-called doomsday device, if you want to use the Dr. Strangelove term, but they have announced that they also plan to automatically and immediately retaliate with nuclear weapons if their leadership or command and control is attacked or degraded.
Thank you. Thank you for clarifying that. Also, I don't want this podcast to cause a nuclear war. So at any time, let me know if we're not able to discuss this.
I think podcasts are pretty safely on the left side of Andrew's typology.
This is the closest my podcast has ever come to being at risk of causing some international incident if we to trip things up. I love it.
Yeah.
As you guys mentioned, this is in some cases, in some sense, risks are not new, right? For 70 to 80 years, we've been, as a globe, working to navigate these enormously complex risks caused by the nuclear reality, right? So, but obviously, there are new risks with AI, and things have changed. I'm curious from both your perspectives, what risk has most elevated? Where has been the biggest incremental shift in risk and concern thanks to AI in the past several years?
Yeah, I don't know. Andrew and I might have different answers here, but maybe I'll jump in. I think in the short term, and by the short term, I just mean the next kind of, this year into probably the end of this decade. I actually think the cyber risks are going to be the most important for most organizations day to day. Some of the other stuff we've talked about, targeting ISR, making the oceans transparent. A lot of that stuff I think is further out, even though I think states will be thinking about that. Why does the cyber stuff really matter? So one of the things that you care about in the world of nuclear strategy is whether or not threats are observable or not to you, right? So when you're in a crisis, let's say, it's a NATO-Russia crisis, where we're moving from peacetime into war. States can observe the other side changing their posture, right? You can observe maybe troops in Poland moving further east. You can move Russia. You can observe maybe Russian forces moving further to the west. There's about to be a major confrontation. You can observe trucks, maybe even nuclear weapons, missiles being moved around in preparation for war. In the cyber domain, you're dealing with a completely different level of observability, which is zero observability, and that matters for the ways in which states are likely to navigate crises, right? So again, you imagine that same NATO-Russia crisis, and you imagine let's say the next Mythos, whatever that is, like some type of exquisite cyber capability that may or may not exist in reality again, right? Perceptions matter here. If the Russians are spooked that the Americans might be able to, flip a switch, like somebody flips a switch in Fort Meade, Maryland at the NSA headquarters and Russia's nuclear command and control systems go down, that's a pretty bad outcome for the Russian Federation. And so those types of risks, whether or not real or imagined, are incredibly difficult to verify, first of all, if they exist in peacetime, right? I can tell you how many nuclear weapons Russia has. I cannot tell you what undisclosed zero-day exploits they might be sitting on that could be revealed in a time of war. And those problems have existed in the pre-ChatGPT, LLM hype era, but the advance of these AI tools is going to make it, I think, much likelier that states are going to worry a lot more about this. And of course, there's a tremendous asymmetry. I've been using Russia and NATO as examples. I don't need to tell you that Russia is really not a player in the frontier artificial intelligence game, right? So the United States is going to be considerably further ahead than the Russians are. And then the China comparison becomes a little bit more complicated because China is a player at the frontier and in a way that would also, I think, give Americans pause about what the Chinese could do potentially to American, space systems, command and control systems. I mean, the U.S. has a tremendous amount of resiliency and redundancy when it comes to nuclear command and control, but you don't know what you don't know about your adversary's capabilities, and that tends to be a driver of instability. So for me, I think that's the short-term concern that deserves the most focus, and then longer term, we get into that some of the other stuff that's a little bit more sci-fi for the moment.
Andrew, how about you? What risks are in your mind most elevated in the AI era?
Yeah, I think broadly, I agree with Ankit. I mean, certainly with dead hand systems, I mean, any system that a human being has built has a probability of failure associated with it. It's why I am not a particularly big fan of the US deploying a dead hand system in response to the Russians, or indeed the North Koreans. And you can read Eric Schlosser's Command and Control for a sense of all the various different failures that have come with nuclear assets. That, like I said, human beings build something and, ultimately, you can't get the risk down to zero, that it won't ultimately fail. And this is particularly problematic in the nuclear space because we suffer from what's called like the always never dilemma. So you always want your nuclear assets available to you when you want to be able to use them, but you never want them to go off unless you really want them to go. And that's a really hard engineering challenge, because everything that you do to increase positive control ends up having a deleterious impact on negative control. And so, it's a big challenge. And so that's kind of that's a piece that's kind of worth thinking about in terms of dead hand systems. I will say that in a lot of the wargaming work that we do around AI implementation, particularly in the nuclear space, the appetite among senior military leaders is lower than perhaps you'd expect for doing some of these integrations. The nuclear command and control network and ecosystem is incredibly antiquated. Indeed, it looks very similar to the way it did in the 1970s and 1980s, which actually affords it some level of robustness to some of the cyber risks that Ankit was mentioning. Of course, as you digitize and update some of those architectures, then you're potentially increasing the attack surface for some of these cyber exploits. So that's kind of worth paying attention to. But over the longer term, though, I think the big thing that would happen inside of the nuclear command and control systems between your radar operator that's providing the signal of early warning to the president and then the president to the missileer, what you're likely to see is just a decrease in the number of human veto players as you move signal from right the radar operator, president, missileer. And so, one of the nuclear close calls that we'll often talk about in the field and that you can see in documentaries on Netflix is the Petrov incident. So this is when a Soviet radar operator ostensibly saw on his terminal 3 nuclear weapons headed towards the Soviet Union, and ultimately he said that's not how a nuclear war with the United States would look. This must be an error, and he refused to pass that signal on to his superiors. He was effectively the veto player.
Yeah, he was the human in the loop.
Exactly.
Yeah.
And so one of the things that you're going to be doing when you're integrating these tools is getting rid of some of those veto players. And then the question becomes, which ones can you afford to get away with losing versus not? Because a lot of what we do is trying to give the president as much time as possible to make decisions, which means decreasing the number of people right in that decision-making chain.
Yeah. So, the Petrov example, I think, is a really good example of, that was basically Soviet GoFi, right? It was good old-fashioned AI. They had a computer system hooked up to these radar systems. In that particular case, it was actually the reflection off some clouds that appeared to the radar like the plumes of rising missiles. But the contemporary version, and I think this gets at Andrew's comment about the reservations that exist in the military about just throwing a bunch of this stuff in because it's the new sexy thing, and we got to have AI everywhere. It's because the military really cares about testing and evaluation generally. And I think there's different cultures around this. I think the Soviets played fast and loose with testing and evaluation. So, for instance, when I talked to former Soviet officers involved in nuclear operations earlier in my career, and the Petrov incident would come up, they would often make the point, it's like, Americans love to talk about that as if the one man saved the world, but like Petrov knew these computers were kind of pieces of crap. Like, we all worked with them. They threw like 50 to 60 warnings a day of false nuclear attacks, but somehow this one story keeps getting told by Americans all the time. But the point I'm getting at is that, today with AI systems, in general, when the military buys something, any piece of technology, be it a weapon system, a software application, there's testing, evaluation, and certification. You want to know that the thing's going to do what you want it to do under the conditions that you expect it to perform in. So that means that for a missile system, you want to know that it's going to be able to deliver whatever explosive yield you need it to deliver against a given target, and it's going to do that with a high reliability, which is probabilistic, but it's going to be maybe 99% of the time it's going to do what you expect it to do. So you can see why testing and evaluation is a pretty tough problem for the contemporary types of AI systems we're talking about, where you have the black box problem. Explainability is still a struggle. And while that's acceptable for, let's say, large financial institutions or corporations, again, when we talk about the extremely high consequence nature of nuclear operations, being unable to reach those extremely high probability estimates that you need for certification is still a problem. And so, there's two answers to that. One is that you don't integrate because you can't get your traditional testing and certification processes to work around these AI systems. And the other answer is that you actually change the way in which you think about risk, because AI is simply too important. And this is like one of the great debates right now, is that, is AI actually too important? If we don't integrate, are the adversaries going to integrate and move ahead of us? So that's where you get into the competitive dynamics that sort of push cultures of safety to potentially evolve over time.
Well, to that point, Ankit, you mentioned earlier that Russia, I think no one would argue that Russia is behind the US and the AI frontier. But one thing I'm wondering is, how much does that matter, right? Because the models are so freaking good already. And even if Russia doesn't have access to our absolute bleeding edge frontier, I feel like even if it's always going to be I'm making this up, 5% worse, as the models constantly improve, the open source models are now almost as good as the tip of the spear frontier labs, right? And so even if it's a little bit worse, what seems to matter most to me is the willingness to make mischief and do bad things, right? If that willingness is there, how much does it matter if it's not the absolute best AI, given what they're already capable of?
Yeah, so I think in the short term, there's a lot that it's not just the Russians, right? I mean, American allies, a lot of the European countries, also, as they figured out with Fable being taken off with export controls, they don't have access to the American frontier unless the United States allows them access, essentially. And so the way I would sort of answer this question is that it matters until it doesn't. And what I mean by that is that until if you are somebody that believes that there is this, don't call it AGI, whatever, there's some threshold to which the frontier labs will eventually get to where the power of artificial intelligence systems will be meaningfully dangerous in military applications, particularly for the kinds of targeting applications that might affect the nuclear balance. The stuff I was talking about earlier about, transparent seas and tracking mobile missiles, all of that stuff. If the Russians get left behind and they're still relying on, let's say, the best open source Chinese models at the time, you still end up with a pretty destabilizing effect. And then longer term, states tend to care about technological sovereignty when it comes to the application of these types of technologies in highly sensitive settings. So how confident would you be as a Russian nuclear operator in allowing a Chinese open-weight open source model to potentially operate in these extremely high consequence environments? You're probably going to feel less confident about that compared to something that you might have developed yourself. And so I think these differences are going to matter more and more as the gap between the American frontier and the Chinese frontier and the rest of the world begins to broaden. And of course, we have 9 nuclear states around the world. And so you have to also think about how many of the other players are going to be coming to this. And the US-Russia example, I still think deserves special consideration because these are the 2 countries that still have the vast majority of the world's nuclear weapons, and the relationship between the two continues to be, I think, very much at the center of what we call strategic stability in the nuclear world.
So, Andrew, Donald Rumsfeld famously said 20-ish years ago, there's the known unknowns and the unknown unknowns. I'm curious if AI in the past several years, has that surfaced any blind spots or unknown unknowns? Oh, there's a whole risk area we didn't even realize, and now we do, and we have to take steps to fix that. And then either one of you, I'd love to hear about kind of how, I think it's a natural on-ramp to the Mythos and Fable discussion, right? Because Mythos is, I think a lot of us are wondering, wow, what has Mythos revealed? And obviously I'm not going to ask you guys to tell all listeners, here is the weakness, the secret Death Star plans that Mythos has showed, right? So, but to the extent you're able to discuss this without engulfing us in a nuclear war or jeopardizing our nuclear safety and security, how is Mythos kind of fit into that the unknown unknowns discussion and the risk it is kind of bubbling to the surface?
Well, certainly, in the open, and you can see this in the press releases around Project Glasswing, which is the effort to bring together a whole slew of corporations that all produce all of the IT that and OT that the country relies upon. There's any number of zero-day vulnerabilities that were found by Mythos that subsequently needed to be patched in operating systems that were previously thought to be relatively secure. Now, obviously, you could have eventually had human operators find them, but I think one of the things that you're getting out of Mythos is the ability to do that at scale and at speed. And so, clearly those were unknown vulnerabilities to those IT and OT, so internet technology and then operating technology providers. So that's certainly something that is a relatively big deal, and is why we're having all these conversations about an export control rule, for Fable 5 and Mythos 5 on the back end. I mean, the thing that I'll point out on the kind of the unknown side of on the nuclear piece, that there's, like I mentioned with AlphaGo, a lot of appetite amongst military leaders to see some of these tools used to create strategy that we hadn't necessarily seen before. And so there's a lot of appetite for kind of AI integrations into wargaming, for example, that might lead to some of these kind of unique insights and what have you. The trouble with doing that, however, is that there's nothing to kind of control it against, right? So what's the empirical record with which to compare your AI-enabled outputs? So Ankit and I have both done some writing in that area as well. And so, fortunately or unfortunately, really, things move relatively slowly in military procurement. And so a lot of these AI integrations are
which is wild given how fast AI is changing, right? So every freaking week there's a big breakthrough in AI. It takes 3 fiscal quarters to
more. More. It'll be more.
Okay.
But also too, I mean, there are some things that stay the same, right? Like ultimately we're talking about time horizons in a nuclear attack that are of the 20 to 35 minute variety. And so AI tools might change that at the margin, right, to being 18 minutes rather than 20, right? And so you're going to lose time in that way. But it doesn't necessarily categorically change the risk that you're actually facing. And so, it's there.
I'd love to follow that thread for a moment here. In that it strikes me as almost an analogy in the business world, where one thing I've seen a lot when I work with CEOs and teams on AI adoption is, in some ways, bigger companies have a massive disadvantage with employing AI, right? Because there's so many layers of approvals needed. There's also more, a $10 billion companies has higher stakes, and there's more customer data to protect, all that kind of stuff, right? So harder in many ways, for like a massive Fortune 50 company to do some basic AI stuff than it is for a really nimble startup of like 4 people or a solo startup person, right? So I'm wondering, is that actually a real challenge in the nuclear military world, where there's an asymmetry where you might have some bad actors that I will say it, like terrorists, right? People like small insurgents groups and organizations that they don't have, it doesn't take them a year and a half to buy new tools. They can freaking do that overnight, right? To what extent has that changed the geopolitical calculus of risk?
I'll go for it. Okay, I've got all sorts of concerns about the defense industrial base. One of the things that the US has tried to do, and that a lot of allies and partners are also trying to do, is to create smaller, more nimble entities that can engage directly with the private sector in particular, because this is something that's really happening, right? Innovation is coming from the private sector rather than Manhattan Project type entities, like the one that actually built the nuclear enterprise as we know it today. And so here in Silicon Valley, we've got the Defense Innovation Unit. It was set up for that purpose by Ash Carter to bring the goodness of the Valley into the military, create relatively nimble contracting vehicles in order to solve this problem. But certainly, sure, you worry about it in terms of like smaller groups, but also too, this is the argument for why China in particular might be able to get ahead of the US in some of these areas, because they can speak with one voice and say, here, private sector, do X, and they will go and do X, right? And that's not how it works here in the US. And our timelines are much, much longer. And so it's something that we're working hard on for sure, but it worries me a great deal.
Yeah, I was just going to jump in here because I think the question about terrorism, I think, also naturally invites a bit of a discussion of proliferation. Does it make it easier for nuclear weapons to spread, for non-state groups to acquire nuclear weapons? The answer to that, I go to a lot of these meetings with, some of the frontier labs where you'll have CB, RN experts. I tend to do the RN part, but then I'll listen to my colleagues from the bio and chem worlds, and I'm actually a lot more worried about what they have to deal with than we have to deal with in the nuclear world.
Sorry, real quickly, can you spell the acronym out for folks who are not?
Sorry. Chemical, biological, radiological, nuclear. And so this is the way in which the frontier labs sort of think about many of the risks. So this is one of the reasons, Anthropic might be required to collect personal identifying information. And, they already built safeguards. If you're trying to prompt the model to help you build a chemical weapon or a synthetic biological agent or a nuclear weapon, they'll try to sort of make sure that, you're not able to get your hands on anything that could cause harm to the real world. But in the nuclear world, so the way I often talk about this is we've actually been pretty lucky that Mother Nature really only left us with 2 isotopes of 2 pretty hard to get. Well, uranium is pretty abundant. Plutonium does not occur naturally, largely speaking, but you need 2 isotopes of 2 elements to build nuclear weapons. They are industrially intense to procure. You have to mine, mill, and enrich uranium. You have to reprocess spent fuel to extract plutonium. And so the industrial difficulty of that has lent itself to verification provisions, essentially, that exist in almost all countries around the world, North Korea and a few others being kind of notable exceptions, Iran being an exception for the moment. And so that means that for terrorist organizations, the bar is still pretty high. And the other thing is we've known since the 1950s that the intellectual barriers to understanding how nuclear weapons work are actually not at all impressive. You had there was the nth country experiment in the 50s where the United States observed that PhD students in their early 20s with training in physics could assemble a nuclear weapon. So the problem is the materials. It's not the secret of the bomb. There really hasn't been a secret of the bomb. This is well understood kind of physics for more than 80 years now. And so I worry less about the proliferation aspect when it comes to non-state groups. What I do think is more pressing, though, is kind of state groups, right? So you imagine the last kind of 30 years of history with the North Koreans, who worked really hard to get to a nuclear weapon that they've now, built and deployed a large nuclear force. Having access to some of the generative AI tools, could help a state-level proliferator. If they're having problems with their uranium centrifuges to enrich uranium, they could, potentially accelerate fixes by relying on some of these tools. They have access to tremendous expertise. They can also maybe solve some of the problems that come with what we call the non-fissile components of weapons. So these are things like, triggers, detonators, the chemical explosives that go into a nuclear weapon. So all of that stuff, I think, is sort of part of the picture. And then the radiological piece of it is also worth maybe talking about briefly. I mean, radiological weapons are different from nuclear weapons. We're talking about just dispersing radiological material to basically, I mean, they're weapons of terror. They don't really have military utility. There again, the concern is nuclear material security. Protecting radiological sources, et cetera.
Mm-hmm.
And so the concerns there, I think, are serious. But I just think that we in the nuclear world live in a very different reality than our colleagues in the chemical and biological worlds, where I think the risks around this stuff, at least in my ears, seem to be a lot more serious with advanced AI systems.
So we could speak for hours and hours and hours and still have hours more to talk through. Sadly, we're almost out of time, but I think we should spend, if you're open for it, at least a few minutes discussing some of the longer term, a little, as you called it, a little sci-fi stuff, because as you pointed out the jump, right, we're discussing extremely unlikely scenarios that have very high consequences. And this might be even amongst that area, even lower likelihood, but also high consequences. And while I think it's might to some listeners sound kind of silly and doomsday and so on, my hope is that there are people out there who are working on scoping out these very unlikely but still possible scenarios. So what would be curious to hear from each of you what you see as the most the risks worth thinking about in that longer term domain, the kind of and I'm not necessarily mean, AI becomes sentient and fires nuclear war at all of us. Not necessarily that, although maybe it is that. Maybe it is something that's worth the extremely tiny edge of the normal curve of risk, but worth discussing. What do you guys see as the most relevant risk there?
I mean, I can kick this off. So, I mean, to pull on the example you just used, right? I'm not going to say AI is going to become sentient, but I think one of the things that people worry about in the nuclear operational domain is, nuclear war, I think, is fairly described as a problem in the genre of what you might term Knightian uncertainty. That's a term from economics to describe just uncertainty that's completely difficult to resolve on the basis of historical data, right? We haven't had a ton of nuclear wars to observe, so none of us, to quote Alan Antoven, the Rand Corporation nuclear strategist, we've all fought the same number of nuclear wars. And so what that means is that an AI system, we know from many of the preprints coming out of the frontier labs that these systems exhibit odd kind of emergent phenomena, right? Whether or not you consider that sentient or not, I don't think we're going to resolve on this podcast. But the system, the models do strange things, and it's unsettling to many folks at the frontier labs. It's certainly unsettling to Anthropic, and so. Given that you have this emergent phenomena, emergent behavior phenomena that comes out of these models, that's that are only getting more sophisticated, more complex. The explainability problem, as Andrew already talked about, is not getting any easier to solve. And then you bring them into the nuclear operational domain, you start to see where this kind of gets into that unknown problem. You've never seen a nuclear war. You don't know what a nuclear crisis might look like in the future. We have some historical nuclear crises to look at, but in that crisis, to have sudden emergent behavior that's completely unexpected and unpredictable, just leads to a whole bunch of kind of just like you get extremely worried about stuff like that happening. And so if you can't rule it out, are you still comfortable with these models operating in those domains? One of the solutions for this problem that I've been trying to bang the drum on is personnel reliability, right? So we have personnel reliability practices in the U.S., which means that if you are a human being that is in proximity to nuclear weapons or nuclear weapons operations, you are vetted. You're vetted for extremist views. You're vetted for a gambling addiction or debts. If you've recently gone through a breakup or a divorce, and you might be struggling with feelings as a result of that, you're actually precluded from potentially participating in your duties with nuclear weapons. And so some of those practices will, I think, need to be updated to account for humans operating with models. And this also includes, just younger generations of humans. We already see high schoolers today are very much they are natives in kind of the AI world, so they are very much used to cognitively offloading to their personal models. And so if you have sort of human beings who are involved in nuclear operations interacting with models on their own time, how do you sort of then ensure that any weird emergent behavior that's coming out of those models is not actually affecting your operational environment? So I think these questions are very much at the kind of organizational bleeding edge at the moment, and I don't think the U.S. Air Force or other organizations have really started updating those practices. But I think this is going to be part of the way to protect against that. And the final thing I'll just say is that I think just a thing to just say in this whole discussion is that AI and nuclear weapons are getting together. Right? This is not a question anymore. And so this whole conversation about where the risks are is basically, as this moves forward, it's not will it move forward, it will move forward. AI and nukes are already coming together. What are the ways in which we should think about these risks? So I'll stop there.
Yeah. Andrew, how about you?
Yeah, I think my answers are relatively similar. I think a lot is going to come down to the how of where these tools meet human operators. So that human machine teaming piece is really important. There's lots of concern about automation bias. And if your listeners haven't seen the Artificial Escalation YouTube video by the Future of Life Institute, they might be interested in giving it a watch. It kind of gives you a sense of a nuclear scenario and where automation bias might be playing, where effectively an AI recommender system is telling a targeting officer, go, 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 right? And they'll give them like a little 3, 2, 1, right? And the idea is that if they don't click the button, right, they're going to lose the war. There's also the flip side of it, which is algorithmic aversion, which can be just as dangerous. We don't talk about it nearly as much. But I think a lot of it is going to come down to kind of implementation in terms of driving risk up and down. And that's why I think it's so important that we understand how having, chatbots living on top of targeting algorithms actually changes the conduct of a war, right? A la Gospel Lavender or the situation in Iran. Because to Ankit's point, these integrations are happening. They're here to stay, right? If you tell the Ukrainians, okay, you can't use autonomy, where they'll say, what do you want us to lose, right? If their autonomous systems are giving them the ability to fight back against the Russians, given their jamming of UAVs. And so really a lot of it's going to come down to that human machine teaming piece. And of course, the trouble is that when your boss, right, buys you an incredibly expensive tool, you're incentivized to use it. And so that also kind of creates its own pathology. So I think a lot of work needs to go into understanding institutionally how you actually create these systems to be kind of safe. And that's going to be a big part of certainly how the US thinks about it, but also hopefully, right, all of the other nuclear states as well. And then the other piece of it, I think that also dovetails relatively well with Ankit's response is that, when we start thinking about marrying AI recommender systems at the strategic level with actually autonomy at the tactical level, there's big questions about whether we actually have appropriate training data to come up with those strategies in the first place. Our end for nuclear use is 2, right? And I'm a war game designer. I build synthetic data that you could ostensibly use to feed the models. I feel pretty uncomfortable with the idea that wargaming data is going to ultimately be helping make decisions about war and peace. And so, there's the data sets that we have for conflict are almost entirely at the lower rungs of what we would call the escalation ladder. And so there's real questions about whether you'd actually have the appropriate training data to feed into a model to then help you make these strategic decisions at the higher echelons of conflict. And that's a really significant challenge. And, I think there can be a little bit of a tendency amongst some policymakers And even some of my colleagues inside the national labs who want a technical solution for all the problems, but ultimately war and nuclear war, it's a human endeavor. And so I think, we ought not to forget that.
Well, we'll have to have a sequel episode because there's still so many follow-ups to all of this. Obviously, a endlessly complex and fascinating topic. Thank you both for helping to illuminate this. Although, if I can ask you a lightning round real quick, each of you, how worried should listeners be about all this stuff? One to 10. Give us a quick your gut reaction of what worry level should listeners have.
I think for the moment, don't start building a fallout shelter if you don't already have one. But look, I think the big picture here is really people debate this stuff all the time, right? Like nuclear deterrence, the fact that why does nuclear war not happen? It's an open question. People debate it. One of the answers to that question is nuclear deterrence, because the bar to starting a nuclear war is extremely high and genuinely seen as a very bad idea, probably a suicidal idea in most contexts. So keeping stability in the main nuclear relationships for the moment is, we're on the wrong trend line. Things are getting worse. After the Cold War ended, things got better for a while. So the bigger picture is really about that. It's about kind of everything else happening in the world geopolitically between the countries that possess nuclear weapons. AI is part of the story. But until and unless we get to that point where, there is this truly kind of disruptive AI model, integration moment where, either the United States or some other country figures out a way to render the nuclear weapons of all other countries potentially moot because they can't be kept survivable or safe or secure, we're generally not going to be seeing, I think, a major kind of stepwise increase in the overall level of nuclear risk. But remember, as long as nuclear weapons exist, the level, the risk of a nuclear conflict is never zero. If it was, nuclear deterrence would not function. So it's one of those kind of uncomfortable facts about the world that we live in that leads some people to conclude that we need to get rid of nuclear weapons, and leads other people, where I personally tend to be, that we have to manage these risks because we're probably going to be stuck with these things for a while.
Yeah.
And Andrew, lightning style for you, Andrew. How worried should we be?
Yeah, no, I agree with Ankit completely. And I think one of the things that gives me some hope is that just, there's thousands of people working inside of the academy, inside of the think tank sector, inside of the military, inside of the government, trying to make sure that these risks are managed appropriately. And they're all incredibly smart, incredibly mission oriented and driven. And that's what keeps me coming back into the office day after day. And so, that's the optimism. That's the hope. And so that's kind of where we are.
Well, gentlemen, thank you for this conversation. And more importantly, thank you for the work you are both doing to help keep us all safe. Thank you so much. Well, there you have it. Thanks again to my guests, Ankit Panda and Andrew Reddie. Thank you to our show's producer, Jasper Chua, and to Garrett Lang for our show's theme music. Thank you to you, dear listener. I hope we do not cause nuclear war from this show. Please do not create any nuclear weapons based on this conversation, but instead, subscribe, rate it 5 stars, send to a friend. Thanks again, and see you next time.